Satellite communications did not start with rockets. It started with an idea. Long before the first satellite was ever launched, scientists were already thinking about how objects could orbit the Earth in a very special way, one that would allow them to remain fixed above the same point on the planet. This idea would eventually change how the world communicates. In the early 20th century, scientists and engineers began to understand that if an object orbited the Earth at the right altitude and speed, it could match the planet's rotation. At around 36,000 kilometers above the equator, a satellite would take exactly 24 hours to complete one orbit. From the ground, it would appear to stay in the same position in the sky. This orbit would later be known as geostationary orbit. In 1945, science fiction writer and engineer Arthur C. Clarke described how satellites placed in this orbit could be used for global communications. At the time, this was still theoretical. Rockets were not yet capable of reaching such altitudes, and satellites did not exist. But the idea was sound, and history would prove it correct. Everything changed in 1957. That year, the Soviet Union launched Sputnik 1, the first artificial satellite to orbit the Earth. Sputnik did not transmit voice or data. It simply emitted a repetitive radio beep, but that beep was heard around the world. For the first time, humanity had placed an object in orbit. The space age had begun. Almost immediately, scientists realized that satellites could do much more than simply exist in space. They could carry signals. The earliest communication satellites were extremely simple. Some acted as passive reflectors, bouncing radio signals back to Earth without amplifying them. A famous example was the Echo satellite, essentially a large metallic balloon in orbit. These systems worked, but they were inefficient. The next step was active satellites, satellites that could receive a signal, amplify it, and retransmit it back to Earth. This was the true beginning of satellite communications. In 1965, a major milestone was reached. Intelsat 1, also known as Early Bird, became the first commercial communications satellite. Placed in geostationary orbit, it enabled live television and telephone communications between North America and Europe. For the first time, satellite communications were not just experimental, they were operational and commercial. Geostationary satellites quickly became the standard. Because they remained fixed relative to the Earth, ground antennas could point at a single position in the sky without tracking the satellite. This made them ideal for stable, continuous communication links. Geostationary orbit solved several key problems at once. First, it allowed continuous coverage of large areas of the Earth. Second, it simplified ground infrastructure. And third, it made broadcasting, especially television, extremely efficient. By the 1970s and 1980s, geostationary satellites were supporting global television networks, international phone calls, and government communications. Latency existed, but for voice and television, it was acceptable. At the time, there was no internet, no real-time data applications, and no demand for low-latency global connectivity. That would change later. As the internet began to grow in the 1990s, satellites found a new role. They became essential for connecting remote and underserved areas, places where fiber optics and terrestrial networks were impractical or impossible. Satellite systems began carrying data traffic for ships at sea, aircraft in flight, oil platforms, military operations, and rural regions. This era also saw the rise of VSAT networks and satellite phones, extending connectivity far beyond traditional infrastructure. However, geostationary satellites had limitations. Their distance from Earth introduced latency. For voice, this was manageable. For internet applications, it was increasingly problematic. A different approach was needed. Instead of placing satellites far away in geostationary orbit, engineers revisited an older idea: low Earth orbit, or LEO. Satellites in LEO orbit much closer to the Earth. This dramatically reduces latency and allows faster data transmission. The trade-off is coverage. A single LEO satellite can only cover a small portion of the Earth at any given time. To achieve global coverage, constellations of hundreds or thousands of satellites are required. Advances in electronics, launch systems, and mass production finally made this possible. Today, massive LEO constellations are being deployed to provide global broadband internet coverage. Unlike traditional satellite systems, these networks behave more like space-based internet infrastructure, routing data dynamically through multiple satellites. This represents a fundamental shift. Satellites are no longer just supporting communications, they are becoming part of the core global network. Satellite communications continue to evolve. Future systems aim to integrate directly with terrestrial 5G networks, support autonomous systems, and even extend communications beyond Earth to the Moon, Mars, and beyond. What began as a mathematical idea in the early 20th century has become a critical component of modern life. From a simple radio beep in space to a connected planet, satellite communications have reshaped how humanity communicates, and this evolution is far from over.